need to first understand how we work on aggregation. We'll start with aggregation, temporal aggregation, and then we first need to understand how does these things work in the non-temporal case, and the second, we will be analyzing this kind of schemas, and then please put your best effort to understand the schemas, because when you understand the schemas, the rest is just encoding.
When you say schema, do you mean this diagram?
The diagram, sorry. These diagrams, this is where all the intelligence should be, and then look at this, there should be many of those. This is what, these are the application requirements. Let's see, this is what, if you have this value, this will be the answer. And then we will compute the same thing in SQL. Okay, you get the idea. So another case, if you have this case, that will be no, yes, no. So try to concentrate on that. If you understand that, the SQL code associated to it is immediately to understand that. So let's talk about aggregation. Aggregation typically in SQL is count, mean, max, average, and all more fancy ones that have been recently added, like standard deviation, etc. So there are two kinds of aggregations in SQL. One is with, and another is without a group by. And this is the main difference. When you say, give me the maximum salary of all the whole enterprise, then you say, select max amount from salary in this table. Because for the moment, forget the temporality. Another kind of request is, you don't want to have the maximum salary overall. You need to say, by department, give me the maximum salary for each department. Okay? So these are the two traditional ways to do aggregation in SQL, and we will try to do the same in the temporal version. So now let's see the temporal maximum overall. So when I say the temporal maximum is, I'm saying I considering here all the employees of my company. For the moment there are only 3 employees here. This employee has 20 during this period, 30 during this period. Here, due to COVID crisis, the company has been on hold. There were no employees, no salary during this period of time. So you get the idea. We have different values, and what will be the maximum, temporal maximum of this salary for this company? In this period of time, there is only 1 employee. The maximum is 20. In this period of time, look, they have another employee here that started here, so I need to compare 25 and 20. The maximum here is 25, sorry. Now we have a new employee, of course, the maximum will be 30 here, but I need to understand that there is a change. So something happened here, I first need to compute here 30 here, and then I need to ask myself the same question, 30, 25, 30, here is 30. The maximum of these 3 employees. Now this employee has a salary raise. He is the maximum, this is the maximum salary for this time. This guy does have a bigger leave here. So I need to compare 35 and 30 is 35 here. Something happened here, so I need to ask my question here. Now I have only 2 employees. I ask myself that, the maximum salary is that. During this period of time, I don't have to ask myself the question. Here I have 35 as maximum, here is 30 as maximum. Do you understand what is the final output of what we want to obtain? Of course, this is not yet the final version. I need to coalesce, merge these 2 periods. I need to merge these 2 periods, and then the result will be okay. Oh, get the idea? So, how do I compute that? The first, the step for doing this aggregation will always be the same. I need to first split the timeline. How do, in simple terms, without going in sequel, how I define this splitting of the timeline? When I should ask myself, during this period, I'm sure that I can, nothing happen.
It depends if when we change the salary or when we have a new salary. Yeah, when we change the salary, then we know that it's a interval.
So you can do every time I have a from date here, a from date here, a from date here. Here I have a to date here. Here I have a to date that ended here. Another interval that ended here. Another interval that ended. So every time there is a from date or to date, there would be a change. There could be a possible change in the value. Okay for that? So this is explicitly here. I have a first, it could be a table or whatever, but here I'm using views. I get all the days when I can obtain from the from date or to date in this table salary. Get the idea? So I collected these vertical lines here. Okay for that? Out of that, I compute periods. I take one of these days, another of these days, ensure that the first one is less than the second, and I cannot take this one and this one. I need to get the next one. So I cannot find another day between the two. Get the idea? When you have that, then basically you have in the periods table here, first interval, second interval, third period here, fourth period. We have as many periods in this table are there splitting of the timeline here. Okay for that? And then this is the most difficult part. Then when you have that, this is the same diagram. I compute the maximum. What I have to do, I take the salary and do a join off with the period. So basically, I need to take all the salaries that are strictly covering the period for which I am asking myself to compute the maximum. So I get, give me all the salaries that have include this period, okay? And compute the traditional maximum, and I say I get the period from the start date and the to date from the period. You get the idea? So again, the difficulty is to understand how do we split the timeline. When we split the timeline, we simply say, for each period, give me all the salary that covers the from date and to date of the period. Look at this, the employees start before or equal and end after or equal. So it's fully containing this period, so it will be included in my maximum here. Okay for that? Fourth step, coalesce the above view with the temporal projection that we have seen at the beginning last time. So this is the easiest case for computing the overall temporal maximum. The other case is compute, a small variant, the count. How does this differ for the count? The only difference for the count that we need to say, instead of having the temporal count will be here I have one employee, here I have two employees, Here I have 3 employees, here I have 0 employees. And the basic idea is we need to do the same, except that we need to do a 0. A 0 during this period, since in this period I don't have any salary that overlaps this period. So this is the easiest case. Now let's go here. Yes.
I'm sorry, could you just go back a bit and explain again what this call as the above view mean? I'm not sure.
Let's start here. Coalesce the above means I need to merge this 30-30 here and this 35-35 here. How do I coalesce here? Using this. Okay for that? So now let's see the other case. Maximum salary per department, by department. Again, all the reflections should be here. What differs here is I need to have a timeline splitted by department. And let's see this example. This employee has this salary and has these two, was affiliated to these 2 departments. The second employee has no salary change, but there is a department change. Third employee, simultaneous change of salary and department. Can someone explain how to split the timeline for department 1? Why it is like this and why the splitting of the timeline is different for department 2? Again, there is no sequel here. You can do the same reflection in R or in Python or whatever.
It's the exact same split as last time. Like you just look at department 1, every time that there's a start date or a to date, that becomes one of your boundaries. And then
But department, so look at this. Let's talk about this particular example, how this 1, 2, 3, 1, 2, 3 landed here or here.
So in my mind, I'm kind of doing these one at a time.
Yeah.
First, I'm going to start with department 1, and I'm going to create a time scale for department 1, and I'm going to look at all my boundaries.
And the boundary, look at this. Here is the first boundary for department 1. This is the employee having 20 and this. So I somehow look at this, I get this. But should I consider also this for department 1?
That's salary, that's nothing to do with the department, so don't.
Yes, but so this 20 here should be accounted in department 2.
Yeah, but you'll get there. Well, that's like step 3 or 4.
Yeah, indeed.
Now just look at department only.
Then, again, I start with department 1 I have here, and department 1 start here, and department 1 start end here.
Yes. And now that you actually have your scale built, now you can go back and look at salaries and say, between this time span and that time span, what was the salary?
Provided that this employee is working on the right department, because for example here, how should I, maybe here, the problem is that they are switching.
So it's just a where statement, right?
Yeah. So you get the idea that we have 2 different scales, or splitting of the timeline, 1 per department. What is the problem here? That, sorry?
Well, why didn't we add 20 to department 2 if that employee moved to second department with the same salary?
So this case.
Yes.
So the idea is here we have a problem. We don't have a problem. How to deal with this issue? We need to somehow split this 20 for this part of the 20 should be accounted for department 1. This part, the other part of the 20 should be accounted for department 2. for to computing the maximum. Okay for that? According to what we have seen until now, which operation allow us to do that? To split this 20 between D1 and D2. It's simply a join.
John O.
A join of the two tables will allow you to split D1 20 during this common period and D2 20 with this common period. Okay for that? In this case, in order to split the timeline, you need to first do a temporal join. So in this case, there is no need for temporal join because the two parameters change concurrently at the same time. But here we need to split 25, compute somehow D2 25 during this period and D1 25 during this period. Okay for that? Once you understand that, the rest is exactly the same thing. So let's see how, look at this. You remember max date to mean date provided that max date is less than mean date. We have just seen that it's just a temporal join between affiliation and salary. So this is the temporal join that somehow splits my intervals. So this table, the first one, affiliation and salary, will provide me two tuples here, D120 until here, D220 until here, and D230 for the same timeline of 30. Okay, from these four tuples, we will have 1, 2, 3 tuples for the temporal join. Okay for that? Once you have that, then we do the split as before by day, but this split, this time split depends on the department number. So you remember here we have one particular split for department 1, another split of the timeline for department 2. So these are the salary changes that now depends on department. So I will take the from date and to date from this temporal join. And then do the periods as we did before, and then do the temporal maximum as we did before. So as you have seen, the complex part is just the time split. Once the split of the timeline is done, the rest is easy.
Okay.
Yeah.
Are we doing the create views just not to write the S for the union?
No, you can have create table or create view. You can have create table and you put exactly like this as. It depends on probably, let me see, performance wise, I need to think which will be better. Probably it should better be a table and not a view because the no optimizer will rewrite these views inside the queries and provide the correct execution plan.
Could you use like the CTE for that as well? Like,
Yes, this is a CTE. Yes, I mean we can do the same CTE like this with affiliation salary, comma, view salary changes, comma. I'm now thinking, I mean the result will be the same in views, in CTEs. If I would need to optimize this, probably I will do independent table because the optimizer will never be able for this complex expression. Imagine one CTE that contains 1, 2, 3, 4 tables plus the coalescing. No, I never will have enough performance. So I will do it step by step in tables.
yeah, I guess my question was because I was just thinking like, if you have like several temporal joins and operations that you have to do, you would end up like with a lot of objects in the database that probably you won't use per se as they are, but are like intermediate steps that you need in order to get the result. But that's just the way to do it, right?
But the idea is, look at this in terms of materialized views. How you need to also assess how often you will need to. What we are doing here is to do a comparison of the two independent variables. We have two independent variables, the departments and the salaries that evolve one independently of the other. Typically, how often you would need to compare find a correlation between the two. If you compute it once, maybe you can compute it for other queries also. You keep it as a separate table. Probably as a materialized view or not, but you get the idea. This is really optimization issues in depending on the application requirement. The important thing is to understand at least how to sketch this kind of operation, so you can write it in your favorite programming languages or in SQL if you need. For example, I was discussing with one former PhD student of the Lamba, and basically they don't even want to put anything, even a PostgreSQL table. They put all the files in a data lake. They don't even want a PostgreSQL database. They do all the machine learning directly from the file. So it's an extreme case, but that happens in company. I mean, there could be a very good reason for doing that. I don't know exactly what kind of, how scale of data they are manipulating. But the idea is, sooner or later, they need to do temporal operations like this, even in R or in Python. So you need to be able to understand this reflection. And then encoding in SQL or your favorite language is less important. You need to think temporal. By definition nowadays, you need to think temporal and understand the issue. How do you program it is successful. Yes?
What is a CTE?
CTE is, for example, instead of doing this here, you can do common table expressions. You can write with, this is a SQL query, with affiliation salary, and then you put exactly the same query, comma, parenthesis there, comma, instead of create view, you put the second name, sal changes, and put exactly the same thing until the as like this. Again, you put the same, and then you put one definition of the table after the other. Okay for that?
Okay, so the name of this process is CTE.
It's common. This is a common table expression.
Okay.
It's the technical term they choose in SQL.
So from Charlotte's perspective,
Yeah.
a common table expression, a view, and a materialized view, kind of as a user, they're all the same thing. There's some sort of a temporary spot to put data, but on the back end, under the hood, these three approaches have a different impact on performance when I'm doing my queries, right? But ultimately, they are a temporary place to put like a subquery or a subset of data.
Yeah, the idea is that we need to incrementally approach the solution, little by little. And here we need 3 steps, even 4, even a 5th steps. And either you can create each of these tables independently, or do in a single pass with CTE, or create views. So there are different ways to express temporary, different steps in the production of your final result.
Okay. But this is almost like, I could, same as we were doing with temporal joins, where you almost have everything in one go, but then you're creating some unions between them. I don't need to use any views. I could just have everything in one mass structure, but then I lose the ability to call it back again.
Yeah.
Because it has to it's increasing my complexity. Is that, or sorry, is it increasing my complexity to not use views for these types of queries?
Look at this. So we have the four table, then after style periods, we have here, I don't remember what is the name here. I choose temp max depth. And then in addition, I have temp max dep, you put the column names as, and then you put the same query. At the end, you have your final query select from where, which is the coalescing, the one doing the coalescing. You get the idea? So we have a very, very long query. One nowadays, what according to the experience of the database management system, what they are doing is rewriting. All this definition of this will be replaced every time you call salaries, and then you get a kilometric expression that the optimizer needs to optimize. But at least for you, so you can write this kilometric one, but at least you are sure that this query is enough. This query is correct, and then you visualize this query is correct, this query is correct, this query is correct, even if at the implementation level, then we all merge in the single one. But you can debug it much better like this.
So it's it's more of a user thing, because
Yeah.
on the SQL side, it's pulling it, dropping it in, it's considering it all the same.
Yeah.
Thank you.
But this depends on the optimizer. Until version 13, until 1 year ago, they were implementing each as a temporary table like this. They put a first, a second, and third. They realized that they miss many important optimizations that they can do with the indexes or something like this. And at the end, they decided that it is much better for the optimizer to run everything into a single query.
And, sorry, kilometric, that's not an actual word, right?
No,
That's
it's
okay.
just
Just making sure I'm not missing something.
yeah, it's a huge complex query. So, what time is it? Yes.
As we are now in the middle of our semester and exams are approaching rapidly, do we have a clue what to expect on exam to be able to prepare ourselves?
Typically, let me see where, yes, I have connection. And
The material is
let me see. What I asked is it, no, this is the data warehouse, sorry. I need to go to the other. Let me go here. Let me see here. If I know. So, of course, I don't pretend that you learn all these by heart. I don't know how I have problem with my connection. Very bad connection. Let me see here. Do I have a better connection? The idea is that, okay, now I have it. Look at this. In this particular example, I have a temporal database, and I asked it to do some triggers for a couple of triggers for this example, a couple of queries for this example, then special database that we will start soon, and at that time we were using object databases. So basically you have an open book and one small schema, and I will ask some traditional queries about this. Look at this. Suppose that here you have a rental database for a real estate application, for which property give the period during which the property was not rented. So the complexity here, what I'm trying to ask you is to identify which piece of code matches here. And you have your book, it's an open book. So you need to, among all the pieces of SQL code that we have been seeing, which according to your understanding enters there.
Temporal difference.
Sorry?
Temporal difference.
Simply. Then you copy paste your solution there, but not talking about incumbents and salaries, but you try to match it to the existing application. Look at these properties rented by contract, by client. So you need to transpose the temporal difference that you understand now very well into this application. And it takes, it's in view, the idea is when you identify, it takes 5 minutes to copy and replace salaries by contracts and these kind of things. So this is how I work in my normal everyday life. I have all the books, I need to do something temporal, then I know how to transpose the pieces of code in the particular application. Okay? I will just finalize a little bit here to motivate the last part, the last tense, the last operator, division. Division is the universal quantifier. So look this example. We have affiliation. This employee works in this department from this date to this date. We have controls. This project number is associated with this department from this date to this date. And we have employees working in projects from dates. Forget for the moment the temporal part, so forget the from date and to date columns. If I want to ask, list the employees that work on all projects to which they are affiliated, forget SQL and then let's speak English. So for those that took the Bachelor 2 course on databases, they know the exercise. I will ask to, in English, give me exactly the same sentence, but I forbid to use the word all.
Every.
No, every all is the same. You are cheating. So you cannot use this concept of all every. How do you say the same thing in English?
That are not missing any projects?
And there is not, so you are already beginning to go closer to not exist. So how would you say that in English? List the employees who
Have not worked in have not worked in any project.
of his department. It's almost like this, but please stay. Let's elaborate a little bit. When you are able to express it clearly in English, it's immediately in SQL. So let's elaborate your proposal. Someone that elaborates Philip's proposal?
There should be another now.
Yeah, there are two knots.
Give me the opposite of.
It can be a possibility.
Well, yeah, it's a not, like give me the opposite of an employee who has worked in, and then whatever Philip said.
No, we should also do a not unaffiliated.
So I will say, give me the employees for whom I cannot find a project of his or her department in which she or she does not work. So I repeat that, give me the employees such that for which there is no project of her department in which she doesn't work. Let me give me the employees such that there is no project in her department such that she does not work in this project. You get the idea? If you understand the formulation in English, you immediately understand the formulation in SQL. Because SQL does not have a universal quantifier, yes?
Why do we do it like that and not the other way around? Is it like too much computation to do without the knots?
How would you propose?
I don't know. I'm just asking.
But for me, there is no possibility to express this for all. If you are forbidden to use the for all, how would you write this without the two not exist?
But so why are we forbidding the use of for all.
Because SQL does not have it, and then I'm forced to do not to a double negation. So in essence, since SQL, there are other very nice language, even for C#, there is a query language for C# that explicitly has a for all. But the people from SQL estimated that they decided that this was not important. It's a major mistake, but nowadays we pay. All the planet pays this major mistake of the designers of SQL. And therefore we need to do this kind of silly thing, which is nevertheless very expensive in computation. But the idea is that nevertheless we need to express a universal quantifier, which is the for all. Give me the employees for which there is no project of her department in which she doesn't work. And this is the sequence of the how we write this in SQL. And of course, as you can imagine, that will be the topic of the next lesson. This table can be temporal. The second table can. There are 3 tables. Each of these can be temporal, and then you have many possible combinations depending on 1 or 2 or 3 of these tables are temporal. And if there is the more complex case, since in this case we have affiliation which is temporal, control this department, control this project, this employee works on this project, and then we need to, again, split the timeline and define for each of these splitting whether it is true that this employee works in all projects of her department. You get the idea? Again, the reflection should be here. When you have there, then we can understand all this huge number of but you know, I cannot even think of daring to explain that without this. You get the idea. And whether you do it in SQL or you do it in Python, it's the same problem. This is easy to understand, and then you suffer to explain it in your favorite programming language. Okay? So we switch to the lab room here, and we start the lab. Lecture of